My name is Elizabeth Pettit, and for Lab 1 of Physics 2211, we were tasked with recording an object at constant velocity. Furthermore, you were tasked with analyzing the video in Tracker and comparing the data pulled from a computational model of an object at constant velocity to the experimental model to see how close the object you analyzed was to an object at perfectly constant motion. This could lead to the exploration of any external forces that may cause your experimental data to not precisely match the computational data that has a net force of 0. To begin this experiment, I rolled a pool ball which acted as the system, and the surrounding was everything around the ball. The physics properties explored were Newton's first and second law of motion. The first law states that an object in motion stays in motion, and an object at rest will stay at rest unless acted upon by an external force. This was relevant because any alterations in the velocity during the experiment displays that the external forces are not all creating a net force of 0. The second law states that the mass times the final velocity is equal to the mass times the initial velocity plus the net force times delta t. This equation can be rearranged to say that the force equals mass times acceleration. This principle shows that for an object with an unchanging mass, if its velocity does not change, the object will have no net force. The goal was to observe an object with no acceleration, that way there was no change in velocity no matter the mass of the object. And since delta v over delta t is equal to acceleration, an object with a net force of 0 also shows no acceleration. The forces acting on the ball were gravity, normal force, the force of the push, and friction. In order for there to be constant velocity, which means there is no acceleration, all of these forces need to cancel each other out to create a net force of 0. The decrease in velocity that I saw during my experimental model was likely due to external forces such as the friction or air resistance not being evened out by the forward forces of the ball, creating a non-zero net force. In the code used to create the predictive model for a ball with constant velocity, I changed the ball's initial position and velocity to match the initial position and velocity of the video that I took and analyzed through Tracker. The mass of the object was changed to 0.17 kilograms, and the change in time, delta t, was set to 0.033 seconds to also align with the data pulled from Tracker. I also changed the formula of the ball's position. The ball's position would be updated by equaling the position plus the change in time times the velocity vector. The net force was set to the 0 vector because for the ball to have a constant velocity, there would be no acceleration. On the graphs of the data, the position versus time of both the experimental model and the computational model are plotted with the predictive code model being in orange and the experimental data being in blue. As seen by the graphs, the experimental data was very similar to the predictive models, but got slightly less accurate towards the end of the 2-second roll because the plotted points don't overlap quite as much. Because the data is approximately linearly increasing line, switching the axes would still show that the object has a constant velocity, but may result in the line being linearly decreasing if the object appears to move in the negative direction in proportion to the origin, which would make the object appear to travel towards the left. However, moving the starting position of the object should not have any effect on the line, as it would have the same velocity. As seen by the differences in the computational and experimental lines on the graph, the pool ball that I rolled was closer to an object with constant velocity at the beginning of the roll than at the end of the 2-second roll. The lack of consistency in the pool ball's velocity was due to the friction and the air resistance that created a non-zero net force. As described by Newton's second law, in order to achieve an object with a constant velocity, the net force would have had to be exactly 0, and then the mass of the object would not play a role. The object that I rolled may have shown these variations from the predictive model due to the deceleration caused by the external forces that slowed the object down. A way to fix this would be ensuring an object moves at the same rate through monitoring its speed during the experiment or through pulling the object on a conveyor belt.